Alright, AP Chemistry, Hoover High School. This is a continuation of the answers video for day 56, lesson 33. And on the last video, we had just concluded doing one of the net ionic equation or net ionic reaction problems. And now we're going to go to a second one. There was a typographical error on this. I corrected it here. On the old version, which I corrected on late Thursday afternoon, it says silver chloride. So that should be changed to silver nitrate, and then you can go ahead and do the problem. Okay, so what you're asked to do is create a reaction, a double replacement reaction between silver nitrate and sodium chloride. Alright, so first we're going to write the chemical formula for the two compounds. So the first one, silver nitrate, is Ag. Again, you get these off the periodic table, you get them from any variety of places. And nitrate, again, is one that's not, it's a polyatomic ion. So you come down here, and there it is. Nitrate right there is NO3. And that's sodium is Na, get that off the periodic table, and chloride is going to be Cl. So those are your reactants. So now you're going to switch places with these two right here. So you'll have AgCl, Cl, and NaNO3. Okay, so that's step one. Step two is, well, actually I did step two. I keep doing this, and that's okay. If you can do them, combine two steps, that's fine. But it says create a double replacement reaction. I already did that, so there that is. Okay, now I'll come down here and I'll rewrite it. We'll determine the charge numbers down here because I didn't leave myself a lot of space up there. So first you have silver Ag, and silver is a 1+, and then you have nitrate NO3, and that's a 1-. So those are already charged balanced. You don't need to do anything to the subscripts. Now NaCl and Na is a 1+. Again, you can get that off of any variety of sheets or just by looking at your periodic table, which would tell you that Na being in the first column, it loses an electron to be like the nearest noble gas, which would be neon. And chlorine is one away from a noble gas on the other side, so it's going to be 1-. So everything there in the reactant side is charge balanced. Okay, now we have Ag 1+, Cl 1-, charge balanced. Na 1+, and NO3 1-. So everything's charge balanced. You don't need to do anything with the subscripts. They are ready to go. So we've basically taken care of that. That's done. Didn't need to be done. Okay, now we're going to use the solubility rules. So I'm going to come down, I'm going to write it again. I'm going to leave space to write that. Okay, so let's get out our solubility rules. AgNO3. So NO3 is soluble with anything, so that's going to be aqueous. NaCl. NaCl is Na is soluble with anything, so that's going to be aqueous. AgCl. We come here and Cl is soluble with anything except these three, and Ag is one of those. So that means these two are insoluble. So they're going to form a solid. And finally, NaNO3, those are both up here. They're soluble all the time. So we're going to put an AQ there. So those are aqueous. They don't recombine in solution. So now you've taken care of your solubility, and you see that you do have a precipitate, a solid that's going to sink to the bottom. Generally, it sinks to the bottom. Okay, that's the precipitate right there. That's your solid. Okay, next up, we got to balance the equation. So let's go ahead and write it one more time. Even writing it so many times, it doesn't take that long to do these problems. Okay, there we go. All right, so we're going to write down the elements. I didn't leave myself any space down there, so I'm going to do them up above because I have a lot of space up there. So we got Ag, we have Na, Cl, and NO3. Nitrate is a polyatomic ion, so we're going to treat that like an element all by itself. It doesn't come apart there or there. All right, and that's everybody, right? Ag, Cl, Na, and NO3. Okay, so let's count. Ag on this side is 1 and 1. Na is 1 and 1. Cl is 1 and 1. And NO3 is 1 and 1. So this equation is already balanced. So this is a real easy one for you to do, at least so far. Alright, so that's that. So now we got to separate all the ions, and that's easier because we don't have any coefficients in front here. So we're going to go ahead and do that. Remember, the ion always is accompanied by its charge and by its state. So this is going to be aqueous. Okay, so this comes together and it does not separate in water. In fact, it comes together there, so that's going to be that. And there's no charge placed above it because it's electrically neutral, +1, -1. And there it is, from one side of the sheet to the other. So start way over on the left when you do these. Okay, so we're not going to write it again down here. We're just going to do what it says. It says eliminate all the ions that appear on both sides. So what do we see on both sides? Na appears here and here. We have NO3 appears here and here. Ag, the silver, appears here. It doesn't appear over on this side. Cl appears here. It doesn't appear over on this side. And AgCl appears here. It doesn't appear on this side. So these are our final elements, compounds in our net ionic reaction. So it's just going to be Ag. And that's your final answer. That's the net ionic equation. Okay, I'll do one more of these for you, and then I'll give you the answer, just the final answer for the last one that you can do by yourself. Okay, so the next one you're going to do on a lined piece of paper. That's the reaction. Be sure you have this reaction on your sheet. I know I made one correction earlier. I can't remember if I corrected these. So be sure you have lead nitrate and lithium bromide. Those are the two that we're going to do. So I have that right here on this sheet of paper. I didn't give you the instructions for this, so see if you can remember them, you know, what the steps are, and if you can't, just go back and do that, okay? So you don't necessarily have to number them either at this point, okay? That's just kind of a tool to help you remember. Okay, so let's get going. So this is going to be Pb, and again, go to your 60 ions for nitrate, if you don't know that one, NO3, plus lithium, Li, and bromine is Br. Okay, so there you've written that. Now we're just going to go ahead in the same step and do the double replacement reaction. So the Pb, which is a metal, is going to switch places with the lithium, which is a metal. The ones in front switch places. Okay, so lead goes over to bromine and lithium goes over to nitrate. They swap places, double replacement reaction. Okay, now we have to check the subscripts and see if everything is in balance. Okay, so we come over here, and lead can have one of two charges, but as long as it has one of the charges that nitrate is, it's okay. So nitrate is a 1-, And lead, according to our 60 ions, is either a 2 plus or a 4 plus. Let's call it lead 2. All right, so I'm going to give lead a 2 plus there. It could have been 4 plus. We don't know. Could have been. Lithium is 1 plus. Bromine is 1 minus. Lithium here is 1 plus. Nitrate is 1 minus. Lead is 2 plus. And bromine is 1 minus. Okay, so lithium bromide and lithium nitrate are both charge balanced. We need to charge balance the lead 2 and the nitrate. So this gives off 2 electrons. This can only catch 1, so you need 2 of these. So the way we write that is like this. I'll go ahead and write the whole equation down below. It's Pb, parenthesis NO3, parenthesis, and then the 2 goes there. So that's, you need 2 of these. Again, treat this like it's a single element. Alright, over here lithium bromide is fine. Lithium nitrate is fine. And we need 2 bromides to match up with the Pb. We need 2 of these minuses. So that's going to be Pb, Br2. Okay, so we've charge balanced everything. Alright, now we need solubility rules to see which of these are going to break up in water and which ones are going to stay broken apart in water and which ones will come together, will bond in water. And it's always in water. So PbNO3 first. So NO3 breaks off with anything, doesn't matter what, so that's going to be aqueous. Okay. LiBr, lithium, is up here. It breaks off with anything. So even though you write them together like this, they're really not together. They were together when you put them in the water, but they're not once they hit the water. Okay, lithium again breaks up with anything, so lithium nitrate. Okay, and finally lead bromide. So there's bromide. It's soluble with everything except these 3, and lead is one of those 3. So that's insoluble. That's going to be our solid. You don't have to always have a solid. You can have all of them be aqueous, in which case you have no chemical reaction. You just have a bunch of loose ions floating around in the solution. But in this case, we do have a solid. And when that happens, by the way, that's termed no reaction. If you had all of these aqueous, it's said to be a no reaction. Even to say, well, isn't breaking up in the water a reaction? It's not considered a reaction unless it recombines and forms a new compound. So that's said to be a no reaction. Okay, and this is a solid. That's the precipitate. Alright, now we have to balance the equation. So let's just go ahead and do it right here. So we have Pb, NO3, we treat as a single element, lithium, and bromine. So Pb is 1 on this side and 1 on this side. NO3 is 2 on this side and 1 on this side. Lithium is 1 on this side, 1 on this side. And bromine is 1 on this side and 2 on that side. Alright, so we got to get bromine to balance, and we've got to get NO3 to balance. So let's go ahead and for the bromine, we need the bromine over here to balance. I'm going to put a 2 right here. So that changes this to a 2. It also changes the lithium to a 2. Okay. Now we got to get lithium to balance. So we're going to change lithium, put a 2 there above lithium. That changes this to a 2. That also changes the NO3 to a 2. And that's good because we needed a 2 over there. So everything now is in balance. 1, 2, 2, 2, 2, 2, 2. So the things, the subscripts, or the coefficients we had to put there. Alright. So I'm going to sneak those in down here. There's a 2 there. You can scratch the temporary one. And there's a 2 there. You can scratch the temporary one. That's a 2. Okay. Now it's time to break everything up into separate ions. So you quite literally start here doing that. So we have Pb. We said Pb was a 2 plus Pb, and that's aqueous at the beginning. And then you have 2 NO3s. So that's not those don't stay together. Those break off into an NO3 and another NO3, 2 separate ions. So that's going to be plus 2. You put the 2 out in front, NO3. And once you do that, you don't have to put parentheses around the NO3 if you don't want to. Let me get on the screen here. All right, and that's aqueous. Everything at the beginning on the reactant side has to be aqueous. It has to break apart. Okay, then we stuck that 2 in there. That applies to both the lithium and the bromine there. So it's 2 Li 1 plus, and that's aqueous, plus 2 Br 1 minus, and that's aqueous. Now we go to the other side of the arrow. You know, you may have to go down to a second line, okay? It sometimes happens. So it's 2 Li 1 plus, aqueous, and then 2 NO3. I think we're just going to squeeze it in. That's a 1 minus, and that's aqueous. And then we have our precipitate, which stays together. And then you don't put any charge because it is electrically neutral once it's together, and that's a solid. Alright, so there we go. This is called the complete ionic equation. I sometimes say reaction, but it really should be called an equation. It's a more proper term. Complete ionic equation. Okay, there it is. Now you're ready to start canceling spectator ions. Find which ones appear on both sides. Again, I like to circle arrows just to be sure it's clear which side is which. I don't make a mistake. Matt, okay. So Pb appears here. It doesn't appear anywhere over on the other side. Leave that. 2NO3 appears here, and it appears here. So that's spectator. That's going away. Okay. 2Li appears here, and it appears on the other side of the arrow. That's going away. And 2Br appears here. It doesn't appear anywhere over here. And PbBr2 solid appears here. It doesn't appear anywhere over here. So these are the Pb, the bromine, and the compound that they formed right there. So you come down here. Okay, and there's the net ionic equation. That's your final answer, all right? So this is how much space it took. It took less than a page to do that. About 2/3 of a page, I would call it, all right? And that's the one I'm going to do for you. Now the last one. And again, be sure this is what you have on your sheet. Again, I had to change some things in this sheet. So sodium sulfate and barium nitrate. Okay, so there they are. So I'm going to let you do that one, and I'm going to put up the answer here in just 1 second. Okay. So this is question D, sodium sulfate and barium nitrate, and I want you to do that one by yourself, but this is the final net ionic equation that you should end up with for that one. Okay, so these are not too bad after you practice them a few times, and that's the only assignment before Thanksgiving. There won't be one on Friday. We'll pick that up the Monday after we come back, so I hope you have a wonderful Thanksgiving, and get together with friends and family. Don't listen to these politicians. They're, I don't know. But just have a great Thanksgiving. And I will be around. If you want to contact me over the break, you can feel free to do that. If you have questions about your grade or about an assignment or anything else. The one thing I would recommend that you do is review kinetics. All right, if you found that was challenging and you didn't quite understand it, go back over the videos 2, 3 times, 2, 3, 4 times, and it will make sense after you do it several times. Work the problems a second and a third time, and so forth. All right, so that's it. Happy Thanksgiving. We'll see you in about 10 days.